Number 3, it says a left-hand Riemann sum. So this is Riemann sum is just LRAM, right? So this is LRAM. So 4 equal intervals. So n is 4. Okay. Used to approximate the area, the R area, under the curve, under the sine curve, right? So my function is f of x equals sine, right? From where? 0 to pi, true? So as you can see this one, Laura, in this case they're asking us to use LRAM. That's what you have to use, right? So we have to first, I would say, make a picture. You can't, there's no easy way to do this. You just have to kind of draw a picture and then figure it out. So we draw a picture. We know sine starts at 0, right? And just draw one cycle, okay? And we know this is 2 pi, right? So what's halfway? Does that make sense? Cool? See, I don't even know what that was, but... And where do we want the area from? 0 to pi, and I'm using LRAM. How many intervals here? 4, right? So we know if we divide pi by 4, what does that give me? Pi over 4, so delta x is pi over 4. So the first one is at pi over 4, and then pi over 2, 3 pi over 4, and then pi here, right? I'm going to zoom in since no one can see, including myself. Is that cool? So now, what we got to do, so now, we're using LRAM, right? So LRAM, we look here, you see my intervals here? Let me just draw them out here. You guys see the intervals here? Okay, so now, the first interval is here, right? Where do I start at? The left or the right? Left. Now, I'm touching the function, true? Which means you go up until you hit the function. Because I'm already here, the height is 0, right? So the first area is 0, right? What about the next one? Well, not the area. So this one's at where? Pi over 4, now I make a box. So what's the height here? That's f of pi over 4, right? Right? Yeah, which is, if you should know, the sine of pi over 4 is what? Root 2 over 2, right? Okay, we'll keep that in mind. The next one is here. And we make a box. I think that's the over approximation here. So this one is f of what? Pi over 2. And lastly is what? F of 3 pi over 4. Okay. Alright. Yeah. I mean, I think it's helpful. I mean, I just think it's helpful, but if that bothers you, we could do it another way. Yeah. Yeah, absolutely. So you can see here, so delta x is pi over 4. So if you remember the sum, it's the summation, right, of delta x times f of xi. Remember that? And this is each of the function values, right? So what were they? So delta x is pi over 4. So it's pi over 4, okay, times something. Now let's see if can we eliminate any already. No. They all have pi over 4. This is a well-made problem. So we say the first one was 0, right? Because I got to add all the area, right? Because look, the first area, Laura, is 0 here, right? So because this is the height is 0 and the distance is pi over 4, right? So you have pi over 4 times 0, right? Plus this box here. This distance is pi over 4 times the height, which is what? Root 2 over 2, right? Because that's the sine of pi over 4. The next one is what? Pi over 4 here, right? Times what? No, the sine of pi over 2. What's the sine of pi over 2? 1. So times 1 here. Okay? Plus what? Pi over 4 times what? Root 2 over 2, right? So you can see how they all have root 2, pi over 4? That's why in this formula, the delta x is already factored out. Because all of them are going to have that base distance. You just take it out. And what am I left with? The first one is what? This was 0 here, right? So what did I put here? 0 plus what? 2/2 plus 1 plus what? Now, you don't have time. Automatically just look for your answer. What's the answer? Let's see here. So wait, this is stupid. This is stupid. This B is the answer, right? Okay, good. Similarly, let's just say you didn't want to use a picture. Edgar, you didn't like the picture, right? So Edgar did delta x is what? B minus A over n, right? And what is B? It's pi minus 0 over 4, so it's pi over 4, right? And then you do pi over 4 times each of the x values. You just add pi over 4 plus this here, right, to get to the first one, which is what? Oh no, you use the first one here, right? The first, for LRAM, you use the first value. So LRAM, you would have to use this here. If not, if it was RRAM, the first one would have been pi over 4.
The last one?
Yeah, with RRAM. Okay, good distinction. And we should write that down. So if you're doing LRAM, you would use the first one, okay? And not the last one. Because did we plug in pi for this one? Did we plug in pi into our function? No. But for RRAM, you would use the last piece here. But for RRAM, you wouldn't use the first one. And then you would keep adding delta x like Edgar did. So it would be 0, and then plus this is what? Pi over 4. Oh shoot, it's f of, right? Plus f of pi over 2, plus f of 3 pi over 4, and that's it. Monday. Alright, and we're done.